Okay, the penetration of a barrier by a particles whose energy is insufficient to transcend the barrier is called a theory of harmonic oscillator in classical mechanics. Quantum theory of angular momentum. Option C, quantum mechanical tunneling effect. Commutation properties of angular momentum. Quantum mechanical tunneling, the penetration of barrier by a particle whose energy is insufficient to transcend the barrier is called quantum mechanical tunneling. In classical mechanics, a particle cannot pass through a potential barrier if its total energy is less than the barrier height b. However, in quantum mechanics, the wave function of psi does not immediately drop to zero inside the barrier. Instead, it decays exponentially. If the barrier is thin enough, there is a non-zero probability that the particle will appear on the other side. Harmonic oscillator, classical versus quantum. The classical harmonic oscillator describes a system like a mass on a spring where the restoring the force is proportional to displacement. Energy, it can have any continuous energy value, including zero probability. The particle is most likely to be found at the turning points where it slows down and reverses the direction. In contrast, the quantum harmonic oscillator is restricted to discrete energy levels. We know En equal to n 1 over half Sv, n equal to 0, 1, 2. If n equal to 0, E not equal to half Sv. Quantum theory of angular momentum. The quantum mechanics angular momentum is quantized for a particle. The orbital angular momentum operator L head is defined as R head P head. Magnitude. The magnitude of angular momentum is given by root under L plus 1 is cot, where L is the azimuthal quantum number. Direction, the component along a specific axis is Lz, ml as cot, where ml is the range from minus L to plus L. Commutation properties of angular momentum. Commutation relations determine the whether two physical quantities can be measured simultaneously with infinite precision for the components of the orbital angular momentums Lx, Ly, Lz, they do not commute. Lx, Ly, Is cot Lz, Ly, Lz, Is cot Lx, Lz, Lx equal to Is cot Ly. This implies that Heisenberg uncertainty principle for angular momentum. The exact value or more than one component of the angular momentum vector at the same time, however, the total angular momentum L square commutes with any single component. L square Lz equals 0. This is why we can define the state with specific values L square and Lz. The penetration of barrier by a particle whose energy is insufficient to transcend the barrier is called the penetration of barrier by a particle whose energy is insufficient to transcend the barrier is called. The correct option is option C, quantum mechanical tunneling effect.